Today we are going to learn about the chapter that is called as a chemical kinetics. Chemical kinetics, which the name itself says that the kinetics means the motion. Somewhere in case of chemistry, this motion, kinetic, that is the motion. It represents actually the motion of the reaction. So here we are talking about the motion of the reaction. Now in case of this chemical kinetics, I can say it's just a part of a chemistry or the branch of chemistry that mainly deals with the motion of the reaction, that is a rate of reaction, or instead of rate I can use a word speed of reaction or the velocity of reaction. So simply I can say chemical kinetics, where we are going to learn about the rate or the speed of reaction. See, as a chemist, it is for me, before starting the reaction, it's a very important to know that what is the speed of reaction, with what speed the reaction will takes place. So it totally depends upon the so for me it is a very important, because once I come to know the rate of reaction or the speed of reaction, then only I can say that how much time the reaction will take for the completion. So chemical kinetics, let's see what actually it is. So it is a branch of chemistry, I can say, that mainly deals with the rate of reaction. There are certain more things which we study in this, which is again related to the rate of reaction only. So it deals with the rate of reaction. The second, it deals with the factor affecting the rate of reaction. And the third, it also deals with the mechanism of the reaction. Again, if I'm using a word mechanism, means I'm not talking about those organic mechanism. The mechanism I'm talking about the mechanism with respect to the rate or with respect to the speed of the reaction. So mechanism of the reaction. So in the chapter we are going to learn about all three. The majority of the part deals with the rate of reaction and the factor affecting, and in between we will learn something. We will see those mechanism also, how the mechanism decide the rate of the reaction. Now I'm talking the factor affecting the rate of reaction. We have certain factor which affect the rate of reactions. Now let's see those factors about which we are going to learn in the chapter also. The first factor, and the very important, that is a concentration of reactant, which affect the rate of reaction. Concentration of reactant. The second factor, temperature. Third factor is catalyst. Fourth factor is the nature of reactant, whether reactant is more reactive or less reactive depending on this, in which state, and the many things. So nature of reactant. So these are the certain factors which affect the rate of reaction. In addition to this, I can say that if there is if the reactants are in a gaseous state, then the pressure and volumes are also responsible for the change in the rate of reaction. So these are the certain factors. So as I said, we are going to learn all these three. So let's start with the first part of the chapter, that is the rate of reaction. How the rate of reaction affect the how to calculate the rate of reaction. So to know the rate of reaction, the first part is, suppose I have a reaction. The reaction is reactant gives product. There is a certain reactant which is giving product. Suppose in the beginning I took 5 moles of reactant, and since it is an initial amount, so initially there will be no product, in a simple word. But after 10 minutes, once the reaction starts, the sum of the reactant will goes on decreasing and the product will goes on increasing. So what I observed, that after 10 minutes, the reactant amount has been reduced, and it has been reduced to 2 moles. So ultimately I will say that the 3 moles of product which has been formed, because 2 moles, it reduces to 3 moles, that is a 3 moles of reactant has been consumed. And if 3 moles of reactant has been consumed, then expected number of moles of product is also, it will be a 3 moles. And this everything happens in how much time? Then I will say it happens in 10 minutes. Now, I just wanted to know the speed of reaction, with what speed the reaction is taking place. So if I wanted to know the speed, that is a rate, then simply the formula for the rate is, the rate is that you just see that what thing is changing and in how much time it is changing. So what thing is changing during the process, and I can say that here I observe that the reactant concentration or the reactant amount has been changed. At the same time, the product amount has been also changed. In how much time? In 10 minutes. So if you want the rate, then just find out that what thing is changed and by how much. So the change amount changes the reactant concentration or reactant amount. How much change? 3 moles. In how much time? 10 minutes. So what will be the reaction rate, or with what speed the reaction is taking place? Simply I will say it is 0.3 moles per minute. Similarly here, what is change? Product. How much? 3. In how much time? 10 minutes. So again it is going to be 0.3. So this is the way how we come to know the speed of the reaction, that is the rate of reaction. This 0.3 mole per minute, 0.3 mole per minute is giving the rate of reaction. Whether you consider the amount of reactant or you consider the amount of product, the answer, that is the rate of reaction, is going to be same. So if I measure the concentration of reactant during the process or during the reaction, or if I measure the concentration of product during the reaction, with the help of any of these concentration, the rate of reaction can be calculated. Now let's see what is a formula, what formula we have for the rate of reaction. So for rate of reaction, the formula is rate is equal to rate of reaction, or in a simply we just write rate. So rate of reaction is equal to, the formula is change in molar concentration of reactant upon time interval, or change in time I can say. Or I can write the same thing in terms of product also, as I said. So it is change in molar concentration of product upon time interval. Okay. So this is a rate of reaction, that is a change in molar concentration of reactant or change in molar concentration of product upon time interval. One thing which is to be kept in mind, that during the process this change is going to be a negative, that decreases reactant concentration, and that is positive, toward the positive increase, positive change, that is the molar concentration of product amount goes on increasing. Now here for a reaction we are considering the molar concentration, while in this case I had just taken number of moles. The number of moles, if you want the rate of reaction, you have to always consider molar concentration of reactant or molar concentration of product. Now what is molar concentration? Then simply I will say molar concentration, the formula we had studied, that number of moles upon volume. The number of moles and the volume should be in liter or dm cube I can say. So this is the formula. So suppose if there is a reaction, consider a reaction, the same reaction which I had written over there. Reactant gives product, and I just wanted to write the rate of reaction. So rate of reaction in short is just written as a rate. It is equal to change in concentration of reactant, delta R. Delta means change, this square bracket stand for the molar concentration, delta R, upon change in time, that is delta T. Or it is equal to change in molar concentration of product, that is change is again delta product upon delta T. Okay, so this is the formula for the rate, change in molar concentration of reactant upon time, or change in molar concentration of product upon time. Again here also one more thing, here delta R, it can also be written as like R2 minus R1 upon T2 minus T1 is equal to, instead of delta P I can write P2 minus P1 upon T2 minus T1, that change. Now let's see what answer I will get. Here R2 minus R1, change in concentration of reactant. What do you think, which is bigger one, R1 or R2? Let's see the example. This is R1 initial amount, this is R2, which is bigger? R1 is bigger. And R1 is going to be bigger because with the time the reactant concentration goes on decreasing. So in initial case the amount is going to be more. So I can say R1 is bigger and R2 is smaller. So answer is going to be negative. Means my final answer, rate of reaction will be negative, which should not happen. the rate or the speed is always positive. And if it is a positive, so to make positive, I'm using here minus sign. Here also minus. So inside the bracket, whatever the term I will get is negative. But with this negative sign, answer is finally positive. Now in the case of this, delta P, P2 and P1. From P1 and P2, I can say this is P1 and P2. The product concentration continuously increases and P2 is a bigger and P2 is a bigger. That is, answer is ultimately positive. So that negative sign which I am using, it is only in terms of reactant, not in terms of product. And or in short, I can say whenever I write the rate of reaction by considering the concentration of reactant, you have to use minus sign in this method. Okay. Now one more formula I have. This is in terms of molar concentration. Now, suppose if the reactant and product both are gases. Being a gases inside the container, suppose this is the container. Reactant and product both are gases. Initially there was only reactant. So those, and since it is a gas, so those reactant molecules continuously move here and there and they are exerting some pressure. So initially the reactant pressure will be very high. But with the time what is happening, reactant is getting converted into product. So ultimately the pressure, since the reactant's concentration decreases, so the pressure exerted by the reactant goes on decreasing, and at the same time the pressure exerted by the product goes on increasing. So I can say that in this case, the pressure of the reactant during the process or during the reaction, if both are in a gaseous state, then the reactant pressure and the product pressure also changes. So to know the rate of reaction here, again I can consider the change in pressure. So the formula will changes to change in pressure of reactant, partial pressure of reactant upon time, or change in partial pressure of product upon time interval. So if I'm writing the formula in terms of product, so what will be the formula? So rate will be equal to, in terms of product I'm writing minus, again here also, change in pressure of reactant upon delta T is equal to change in pressure of product upon delta T. Again no minus sign with respect to pressure, but with reactant you have to use again minus sign. So now this is the formula for the rate in terms of reactant, but throughout the chapter we are following this formula only. That is, we are considering the concentration only in terms of reactant. Somewhere it is given, but otherwise we don't use this formula. That is, rate is equal to minus delta PR upon delta T. That is in terms of pressure. Now let's see the unit of rate of reaction. What will be the unit of rate of reaction? Okay, so the unit of the rate of the reaction, for unit of rate, again I can first I'm writing the unit of rate of reaction in terms of molar concentration. Molar concentration of reactant or molar concentration of product. So the first one, the unit of rate of reaction in terms of molar concentration of reactant or in terms of molar concentration of product. See, molar concentration, here we have numerator. Molar concentration upon time. Time, it is minute, second or hour. So molar concentration, that is, it is moles in numerator. Upon volume is liter. So the unit for the molar concentration is liter, mole per liter. Or sometime instead of liter I can use the term dm cube also. Or instead of using mole per liter or mole per dm cube, the molar concentration unit is also represented by capital letter M. So the unit for the rate of reaction, it is the unit of molar concentration upon the unit of time. The unit of molar concentration we have mole per liter upon time. For a time being, I'm just writing the time per time, but keep in mind that while writing a unit, you have to mention the unit here, that is whether it is in second, minute or hours. Or mole per dm cube per time. Again, per time you have to mention which unit is given. Or instead of mole per dm cube or mole per liter, I said molar concentration is also represented by capital M. So molar per time. Then, so these are the units of the rate of reaction in terms of molar concentration. The meaning of all the units are same, only the way of writing is different. Then second, In terms of pressure, if I'm using that pressure formula, now let's see what will be the formula if I'm using pressure unit. So formula for the pressure is what? Change in pressure of reactant upon time or change in pressure of product upon time. That is the formula. Unit will be pressure unit upon time unit. The pressure unit is atmosphere upon time means per time, or instead of atmosphere I can write Newton per meter square per time, or I can say if the Pascal is given then Pascal per time. But again, while writing you have to mention that unit of time also, whether it is if second then per second, per minute, per hour. Don't write the same. So this is about the rate of reaction, the formula for the rate of reaction and its unit. The formula can be written in terms of reactant concentration as well as in terms of pressure. Similarly, unit can also be written in terms of concentration as well as in pressure. But while in the chapter, the rate of reaction, generally we use the change in terms of concentration. The pressure change is not considered here.